This is P, A, f of A. So now the same thing, you will have to say that limit is there. You will have to tell me f of A plus H minus f of A divided by H. But now when Q gets closer and closer to P, what do I write? Exactly. So we have two definitions for f prime of A, either the one with H, either the one with X approaches A, whichever you would like to use, and one definition for the derivative. So I would like you to next choose a problem, and then I'd like to look at some word problems. Find f prime of A using the definition. We work on a square root. We work on a cube root, on the cubic function. I recommend I know we've had 2 quizzes on this, so this should be just a breeze right now, right? Let's find f prime of A for this function. Now choose which definition you want to apply. You want to apply the one with H approaches 0, or you want to apply the one with T approaches A? Which one? H approaches 0? Okay, perfect. Perfect. I lost track of my pages. So we picked problem 29 on page 151, and we are given f of t, which is 2t plus 1 over t plus 3. And we're asked to find f prime of A. Yes, please, Sarah?
Could you zoom it out?
Oh, yeah, of course, no one can. I'm so sorry. Thank you. Ready? So we decided to use the one with H. I would recommend the other one because we've done the one with H a lot, but it's fine, we can do both. So we stick with the one with H or the other one?
Yeah.
Okay. Is that okay, Noah?
Sure.
Do you want to, we can do both, I don't mind. We want to do both? Okay, so f prime of A, limit as x approaches A. Of course, x minus A. Ready? So, what do we do? Sorry, t approaches 0. T approaches A. There's no x here, sorry. Okay, so what do we write? So, what do I write? It's the function, right? There is no discussion there. It's the function, right? Okay, so then 2t plus 1 over t plus 3 minus Is that what you said, Andre? Good, perfect. If you plug in A, what do you think you're going to get? Of course. Which is the factor that must go away? For sure. In the one with H approaching 0, H must go away. Because that H is the problem. H created 0 with 0. Which factor creates 0 with 0 now? Which factor creates the 0 with 0 now? minus a, right? T minus a. When t approaches 0, when you plug in a and you get 0, then t minus a is the factor. Right? We remember that? Okay. So keep that in mind. T minus a has to come out as a factor from the top. Good. So then, please dictate the top. What do I do? Other than run out of room? Yes, thank you. This definition with x approaches a is, or t approaches a is not as difficult, I think, in certain situations as the other one with h. Okay, the least common denominator. Very good. Top here. Perfect. And t plus 3. So let's dictate, or can anyone dictate? Let's distribute a first. 2at plus, very good, plus 6t plus 3 minus 2at minus
T.
yes, minus 6a minus, good. See why I recommended this one? Because if you replace t by t plus h, then you will have 3 terms in the denominator. So for rational functions, I recommend this one versus over the other one. So anyway, this is limit t approaches 0, t minus a, which was t minus a over 1, so I flip t plus 3, a plus 3. We know what has to happen at the top. I don't even look. I know what's going to happen. What's going to happen? Yeah, some of the terms have to go away, the ones that do not have a factor of t minus a. If they don't have a factor of t minus a, because now it's not h in the denominator, but t minus a. If they don't have a factor of t minus a, they have to go away. Negative 3 with positive 3. Negative 2at with positive 2at. And I see 6t with minus t, which is 5t. And I see negative 6a with plus a, which is minus 5a. The remaining terms have t minus a in common. Because I am waiting for it to go away. It must go away. So from the top, you will factor out. And you get t minus a, t minus a, t plus 3, a plus 3, goodbye t minus a, and only now I drop the limit operator, and I see that the final answer is the top goes to, perfect, the denominator goes to, so when t approaches 0, I'm sorry, of course. When t approaches a, I have a plus 3 to the second power. Thank you. Great job. Any questions on this? Any questions? Any questions? Okay, I would like to look at a couple of more problems. And here's one. It's an application. A roast turkey is taken from an oven when its temperature has reached 185 degrees Fahrenheit and is placed on the table in a room where the temperature is 75 degrees Fahrenheit. The graph shows how the temperature of the turkey decreases and eventually reaches or approaches room temperature. By measuring the slope of the tangent, estimate the rate of change of the temperature after an hour. So after an hour, which is 60 minutes, they already drew the tangent for us. So I'm going to try and estimate this.
Obviously, it's a negative slope. I'm going to say that this is, so this is 50. This is 75. I'm going to say this is maybe 85. And this is roughly 150. I'm trying to estimate this here. Maybe half will be 15, so I'm going to say 14. And here roughly, so half is 100, right? I'm going to say 110. So I have a negative number between 85 and 50, and between 14 and 110. So the rate of change of temperature with respect to time. So that was problem 42 on 151. So the slope of the tangent line at P appears to be negative, of course. 150 minus 85 over 110 minus 14. Is this accurate? Of course not. I had to estimate. I couldn't determine it. The graph wouldn't permit. Okay, so whatever this is, I need the measurement unit. Remember, the measurement unit of a rate of change is built or constructed with two measurement units. The measurement unit from the top over the measurement unit from the bottom. So if you're calling me and you ask me what is your rate of change, I'm driving, and what is your rate of change, I would have to say 40 miles. But that would be incorrect. I have to say 40 per hour, because it's a rate of change of distance with respect to time. So every time we're talking about rate of change, we have to have two measurement units, one coming from the top and one coming from the bottom. So did you get this number from me? But please give me the measurement unit. Degrees Fahrenheit per minute. So what was that? Do we have a number there? Did you divide for me? Okay, I got 0.678 degrees per minute. It decreases. It's negative, of course. Negative. The temperature decreases at a rate of negative or 0.6. It decreases. If I say decrease, I don't have to read the negative. 0.678 degrees per minute, degree Fahrenheit per minute. When? Exactly an hour later after it was taken and put on the counter. It's not going to be the same rate later. If you look at the graph, the rate changes. So obviously, this highest rate is up here. Then slower and slower and slower and then slower. So at every point, there is a different tangent and a different rate of change. Any questions? Any questions for me? Okay, I'd like to look at another word problem. I thought I had the eraser here. Yeah. So, another word problem. Any questions on this one? Any questions? Okay. Let's look at if the tangent line to y equals f of x at 4, 3 passes through the point 0, 2, find f of 4 and find f prime of 4. So let's take it slowly and let's copy this information first, see what it means. So this is problem 20 on page 151. If the tangent line to the graph y equals f of x, the tangent passes through the point 4, 3, and point 0, 2, Find f of 4 and f prime of 4. Let's read this one more time because I didn't write it correctly. So the tangent to this graph at the point 4, 3 passes through point 0, 2. So here's the graph. Here is the graph of a tangent. This is the graph of f of x. And here's the graph of a tangent. And let's suppose that this is 4, 3. So the tangent to the graph passes through the point 0, 2. So this is the tangent, and this is the function. So the tangent that to the graph of f of x at 4, 3 crosses the y-axis at 0, 2. We're asked to find two things, f of 4 and the derivative or the rate of change of the function at 4. The instantaneous velocity, the instantaneous rate of change. So what do? First of all, can anyone identify f of 4? F of 4? Of course. That's the point. F of 4 must be 3 right here. We know that. So now we want to find f prime of 4, which is the slope of this line. How do I determine the slope of that line? Any suggestions?
Use the slope of the line between point 0 and 2.
I have 2 points, of course. Of course. So that will be 3 minus 2 over 4 minus 0. So this is 1/4. The rate of change of the function at 4 is nothing else but the slope of the line that passes through 4, 3 and 0, 2. Of course. And that is the slope of the tangent line, and that's the rate of change of the function at that point. Yes. More word problems. Ready? Any questions? Okay, so let's take a look. Okay, so let's read 48. The number of bacteria after T hours in a controlled lab experiment is function n of f of t. So it's a function f. The independent variable is t, and the dependent variable is n. We normally write y equals f of x or f of t. So this was the dependent, and this is the t is the independent. What is the meaning of the derivative f prime of 5? And what are the units? So bacteria, so the number of bacteria n, it's number of bacteria, and t is number of hours. And we want to find the meaning of f prime of 5. So let's write this down. So this is a problem 48 on page 152. And we have n equals f of t. We're asked to find f prime of t, which is f prime of 5. So t is in hours. And this is number of bacteria. What does f prime of 5 mean? How fast is the number of bacteria changing 5 hours after the initial count? So how fast the rate of change of the number of bacteria 5 hours after the start of the experiment? 5 hours. Measurement unit. So the rate of change of the number of bacteria oops, I didn't mean to continue like that, after 5 hours from the start of the experiment. So measurement unit. Number of bacteria per hour. Very good. Part B. Ready? Can we see part B? I can see from here. Suppose there is an unlimited amount of space and nutrients for the bacteria. So unlimited nutrients, unlimited space. They can multiply as many times as they want with no limits. Which do you think is larger, f prime of 5 or f prime of 10? If the supply of nutrients is limited, would that affect your conclusion? So we are comparing f prime of 10 and f prime of 5 for unlimited nutrients and space. So f prime of 5 and f prime of 10, unlimited and limited. F prime of 5 and f prime of 10. If the space is unlimited, when do you think the rate of change will be faster? When there are 5 bacteria, they will grow faster than when there are 10 bacteria. Chris already gave us the answer. He said absolutely when there are 10, because they can freely multiply as they like. But now, what happens when the space and nutrients are limited? Small space. They grow fast at 5, but then there is no more room for them. When they get to 10, they have to slow down because they can multiply unlimited. So they definitely have to slow down at f prime of 10. F prime of 10 must be smaller than f prime of 5 because they can do whatever they want. They're restricted. Any questions? Any questions? That's basically everything I needed to say as new material. And since we have 10 minutes left of 12, I would like us to start reviewing for this test. So I'm going to pick a couple of limits from page 167 where the review for this test is. And I'm going to watch you work. So here's an example, problem 12. Limit Sx approaches 3 from the square of x plus 6 minus x over x cubed minus 3x squared. I copy problem 12, the square of x plus 6 minus x, x cubed minus 3x squared. Okay, 2 minutes. If you need help, please let me know and I'll come and help you. I'm putting the attendance in. Do we need more time? Andre, Eric, Chris, Bella, Sarah, Greg is not. Kyle is here, Jake, John, Sam, Jason, Kylie, and Eddie. Okay, ready? So first of all, I recommend factoring out x squared, x cubed in the denominator, of course. Although, actually, I jumped to conclusions too soon. When I plug in 3, I get 0 over 0 because of x minus 3. So I'm just going to factor out x squared into x minus 3. And of course, I'm going to rationalize x plus 6 plus x, the square of x plus 6 plus x, and I get x plus 6 minus x squared at the top, and the square of x plus 6 plus x. Do we have this so far? So I rationalize the numerator with the conjugate, the square of x plus 6 plus plus x. And when I multiply, it's a minus b times a plus b, which is a squared minus b squared. In the denominator, I factor out x squared. And I know which factor has to go away. Which factor has to go away if the limit exists? The factor that has to go away is x minus 3, right? X minus 3. That's the problem. Okay, so now can anyone give us the factored form of the numerator? With minus in front. So first of all, I have x squared minus x minus 6. And then the top is, after I factor, I better find what factor for sure. It has to be in there. If it's not, I have to start from scratch. Something is not right. I know it's there because when I plugged in 3, I got 0. It has to be there. So then x minus 3 and what else? Very good. I eliminate the problem by simplifying by x minus 3, and only now I can drop the limit operator and you will tell me what to write.
X plus 2 or square root of x plus 6.
So when we plug in 3, we have minus from here. 3 plus 2 is 5. And then 3 squared will be 9 times 3 plus 6 is 9. The square root of 9 is 3, and 3 plus 3 is 6. So the final simplified form is this. Any questions? Any questions? We have 2 more minutes, and a very simple one, short. Very simple, short also. Any questions on the previous one, please?
I do.
Yes, please.
So you can't use a calculator for that one?
You can to check.
Okay.
It has to be an algebraic proof
Okay.
from the beginning to the end. If you want to check, you can, it's fine. But no credit can be given for that. Okay, so e to x minus x squared. e to x minus x squared. Thank you for asking that. So I don't want anyone to miss anything. Yes? Where do we start? Well, the answer is from the inner function. This is the outer. We start from the inner. Can anyone tell us where does the inner function go when x approaches infinity? Which of these two quantities is the most powerful one? The x or the negative x squared? Right, right. So this is too small, don't worry about it. So where does this go then?
Negative.
Awesome. So now I shouldn't write this. It's not legit, but I'm going to write it. This is this. Where does this go when x approaches infinity, which infinity? And now we know where does 1 over infinity go? Indeed. Which means y equals 0 is what? At only. I have no idea what happens at the other end. I can't conclude.